Right. Can you all hear in the chat? Can you all let me know? If you can hear clearly, put a thumbs up. Give it a thumbs up for the video. Okay. Is it clear? Or you can send me a WhatsApp. One person, if it's clear, quickly send me a WhatsApp. Will. Is it loud and clear? Superb. Okay then. Good evening back again. We'll continue our helpline session. Getting you started, getting you studying. So we stopped at page number 9, question number 30. So we'll continue from there. Okay. Page number 9, question number 30. So we'll continue from there. Right. Question 31. Question 31. A crown of mass 1.4 kg has an apparent weight 1.3 kilogram when submerged fully in water. So remember, submerged fully in water, that means we can directly connect it to the relative density. The mean density of the material of the crown is, so relative density of the object, we can say 2 weight divided by 2 weight minus apparent weight in water. Apparent weight in water. Apparent weight in water. 2 weight minus apparent weight in water. So true weight here is 1.4 kilogram. Apparent weight is 1.3 kilogram. So from this you have 1.4 divided by 0.1, 14. Density of the object divided by density of water. First multiply. Density of object equals 14 multiplied by 10 to the power 3. 14 multiplied by 10 to the power 3. Simplified further. 1.4 10 to the power 4 kg m minus 3. Which is answer number 4. Which is answer number 4. Okay. So pretty direct calculation. MCQ 32. MCQ 32. MCQ 32. A tube of length L is fitted to a vessel having a height L and a bottom area A as shown in the figure. So here you go. This is liquid, length L here, and this is capital L. This is capital L. Right. They are telling you the bottom area is capital A, Bottom area is capital A. Bottom area is capital A. And the cross section area here is simple A. What are they asking? The force acting at the bottom of the vessel is equal to, remember this, the hydrostatic pressure force. All of you all know the hydrostatic pressure force here. Don't forget, it will be PATM. So PATM plus simple L plus capital L rho G. Whole thing times area. Don't forget again from the bottom, PATM times A. The net force acting is going to be, net force is going to be A times L plus simple L rho G. So from here you have your answer. Answer number 1. Answer number 1. Answer number 1. Question number 33. Question number 33. Have a look at it. A cylindrical metallic vessel having thin wall of height 4h contains water up to height h. So there is water inside. When immersed in water, this cylinder floats with half of the height below the water surface. So they are given you the initial diagram like this. Have a look. Initial diagram. Initial diagram. Right. So here you have water here, 2h. And there is water here as well. Inside here, H. Inside here, H. Outside here, there is another 2h there. Right. What are they asking? If the cylinder is to be floated with its almost entire height underwater, the water level inside the cylinder has to be raised from H to how much? Right. Now they are saying, if the complete cylinder should be underwater, that means 4H is underwater, up to what height you should fill water? Up to what height you should fill water? Or the height should increase from where to where? Right. Now you can carefully work this out. Let's start with basic. What's the basic? The beaker has a weight. I'll name it as M1G. Here the water has a weight MWG. Also, the vessel is submerged. There will be upthrust acting on the vessel. There is upthrust acting on the vessel. Right? So, sum of forces in the upward direction balances sum of forces in the downward direction. Upward forces you can say U1. Downward forces you have weight of the beaker plus weight of water. I take M1 as weight of beaker. Weight of beaker. Right. Upthrust is submerged volume. I take the area as A. Submerged volume is A times 2H. Density of water into G. M1G plus. What's the weight of water inside? AH rho WG. Take it this side. Simplify. AH rho WG equals M1G. AH rho WG equals M1G. There you go, equation number 1. Now your calculation here. Weight of the beaker is there. New weight of water is there. And don't forget the whole thing is submerged. Upthrust is also there. I will mark upthrust here on the beaker. Upthrust on the beaker. Sum of forces in the upward direction balances sum of forces in the downward direction. Sum of forces in the upward direction balances sum of forces in the downward direction. Upward direction we have U2. Downward direction we have weight of water MWG dash plus weight of the beaker. Weight of beaker already I have found. Upthrust is, don't forget the area, A times 4H rho WG Weight of water is AH dash rho Wg. Weight of the beaker is AH rho Wg. Take it to the other side. 4 times AH rho Wg minus AH rho Wg. 3 times AH rho Wg equals AH dash rho Wg. A rho Wg cancel off. H dash equals 3h. H dash equals 3h. So I must raise the water from H to 3h. If I raise the water from H to 3h, I can achieve this. So the correct answer is answer number 4. Correct answer is answer number 4. Correct answer, answer number 4. Right. MCQ 34. Now we have done this. Directly when you see, you know what's happening. A beak of water is kept on a compression balance. At the time t equal naught, a solid hanged object immersed just beneath the water surface and lowered slowly down. So we know when you lower slowly down, what happens to tension? Tension will reduce, reaction will increase. Quickly you should remember. If there is a spring scale on top, here reaction scale. Spring scale on top means tension will reduce, become constant, drop. Reaction scale will increase, become constant underwater, and then suddenly peak. Peak can become constant. This is given. So what are they reading you? It's already submerged. So already submerged means this part we are not talking. So what you learned in theory is from the beginning. No? From the beginning you are submerged. From the beginning you are submerging and going. From the beginning you are submerging and going is this part. Now what are they told in the problem? Object is hanged, submerged inside the surface. So inside the surface means this part is already done and finished. So this part is not there. So what you have is from here. So from here reading is constant. When it touches the bottom, it will increase. So already inside, constant value. Touches the bottom, reading will increase. From this, your correct answer is answer number 1. So be careful. Just because you know the complete theory, don't go and look at the graph and underline graph number 2. Graph number 2 will come if you submerge from outside to inside. That is not happening here. Already the object is inside. From inside only it's going down. So already there is a reading. Once it touches the bottom, quickly it will peak. Okay. Right. Question number 35. Question number 35. Question number 35. A uniform solid cylinder weight 6 Newton is floating vertically in a liquid with part of its weight height fully in the liquid. So weight of the object is 6 Newton. Weight of the object is 6 Newton. Part of the height submerged. Part of the height submerged. The minimum vertical force required to immerse the cylinder completely. So what is the minimum vertical force? Minimum vertical force with the weight to completely submerge. Now think carefully. Here what's happening? Downward forces, balances, upward force. Downward force is weight. Balances upward force, up thrust. If I take the area as A H over 4 rho Wg. You can see A constant, rho W constant, G constant. So 6 is proportional to H over 4 I can write. Here downward forces, balances, upward forces. Minimum force downward plus 6 Newton equal. Area is AH rho Wg. You can see clearly A rho Wg constant. So minimum force plus 6 Newton proportional to what? H. Equation 2. Divide the second equation by the first equation. Minimum force plus 6 divided by equals H divided by H over 4. Minimum force plus 6 divided by 6. That is 4. Cross multiply. Minimum force plus 6 equals 24. Minimum force equals 18 Newton. Minimum force equals 18 Newton. The answer is not there, but that should be the answer, 18 Newton. Okay, no? 18 Newton. Because 6 Newtons to submerge HO4. To submerge fully means it should be 4 times more than this. 24. 6 is already there, 18. Okay, right. Next one. Next one. MCQ 37. This also we have done in theory. You keep a beaker inside a lift, lift is falling under gravity. What will happen to the upthrust? What will happen to the submerged height? That's what they're asking. It's coming down under it's coming down with acceleration A. What's happening to the upthrust? Upthrust will, the submerged height will not change. So submerged height remains unchanged. Answer is answer number 5, directly from your theory book. Directly from your theory book. MCQ 38. A rocket carrying 1.8 kg oxygen in a vertical tank, cross-sectional area 3 meters squared. At liftoff, it accelerates it 2 ms minus 2 upwards. Pressure at the bottom of the tank. By now, you should know this, huh? Because I have taught you this in theory. Here, liquid oxygen or whatever is there, when this is accelerating, this will affect the pressure there. Absolute, or we say gauge pressure. Gauge pressure is H rho A plus B. That will be the gauge pressure acting. That will be the gauge pressure acting. They are asking the pressure at the bottom of the tank. So that's the gauge pressure. Gauge pressure. So here you have height. Tank cross-sectional area is given. It will accelerate vertically upwards. Pressure due to the weight, you can multiply into force. So pressure is force over area. Let's do the basic calculation, right? So if you apply F equal ma in the upward direction, you can see these are accelerating upwards. You have weight to take the liquid here. It's also accelerating upwards. The weight of the liquid is acting downwards. Weight of the liquid is acting downwards. So if you look at it very carefully, upward force minus weight, 1.8 10 to the power 4 times g. Mass is 1.8 10 to the power 4 times acceleration p. F 1.8 10 to the power 5. Simplify this. 3.6 10 to the power 4. F is equal to, simplify, 1.8 10 to the power 5 plus 3.6 10 to the power 4. That's about 18. 18 plus 3, 21.6 10 to the power 4. That is the force acting at the bottom. So the pressure acting at the bottom there is force divided by area. 21.6 10 to the power 4 divided by 3. 7.2 10 to the power 4 Newton per meter squared. 7.2 10 to the power 4 Newton per meter squared. Answer is answer number 5. So here there will be a force acting. Force accelerating it, or force acting here. Here you have the weight in the opposite direction. Apply F equal ma, find the force. Once you find the force, force divided by area at the bottom will give you what? Easily answer number 5. These are basic theory works, huh? If you have learned in theory. MCQ 39. Flat bottom U-tube. I told you, whenever you see a flat bottom U-tube, tan theta equals A over G. So if a flat bottom U-tube is accelerating, in theory, be nice to prove this. Here you go. Height difference is H. Length is L. So tan theta here, tan theta is equal to H over L, A over G. We have proven this. What are they asking you? Difference in level. H is equal to AL divided by G. AL divided by G, you have answer number 1. AL divided by G, you have answer number 1. These are very direct questions. Very direct questions. MCQ 43. MCQ 43. Figure shows the balanced position of a light rod carrying an object. So here you go. Pivot point is here. This is L. This is L1. Here you have weight, capital M. Here you have another weight, let's say X. So object X, mass M, balanced position of the same system when X is immersed in water. If the density of water D and the density of material is X is given by. You can take moments here. So capital Mg, you can put here Xg with the weight, no problem. Clockwise moments equals anti-clockwise moments. Clockwise moments, capital Mg L1, anti-clockwise moments, Xg into simple L. Gg cancel off, ML1 equal X simple L. X is going to be the true weight, ML1 divided by simple L. 2 mass. 2 mass. Now it's fully immersed in water. So, 2 weight, apparent weight connection. Now fully immersed in water. Once you are fully immersed in water, here the length changes. Here capital M is there. Now X is fully immersed in water. Fully immersed in water, there you go, density D. Now tell me, what are you balancing here? You're balancing the tension. What is tension? Tension is the apparent weight. Apparent weight of the object in water. So here you go. The true weight of the object. This true weight of the object. Now basic work. True weight. Now once I submerge it completely inside, now when you take moments, you're taking moments with tension. Now tension is what? Apparent weight. Guaranteed you should remember. Tension is apparent weight. Now take moments, moments about O, clockwise moments equal anti-clockwise moments. Now here you have capital Mg. Don't forget tension is there. So again, clockwise moments, capital Mg L2, anti-clockwise moments, tension into simple L. Tension equals capital Mg L2 divided by simple L. L2 divided by simple L. So in kilograms, if you write, P in kilograms, ML2 over simple L. In kilograms, this is the apparent weight. Apparent weight in water. Apparent weight in water. Okay. What do they want? They want the density of the material. So what? Density of the object is, or relative density of the object, density of object over density of water is true weight divided by true weight minus apparent weight. True weight minus apparent weight in water. Apparent weight in water. Apparent weight in water. True weight is equal to capital ML1 over simple L. Capital ML1 over simple L. ML2 over simple L. ml cancel off. Density of object over density of water is B. No? Density of water is B. From here now you can simplify and write. From here simplify and write. Density of object is L1 divided by L1 minus L2 times B. What is your answer? Answer is answer number 1. So ideal question, huh? Sometimes they can ask question like this, a structured also. So true weight you find separately. Once you fully submerge in water, you can find the apparent weight. Now apparent weight will be the tension. Apparent weight separately. So once you know the apparent weight in water, don't forget this equation MCQ. Density of the object is true weight divided by true weight minus apparent weight. Apparent weight in water. Substitute, common terms cancel off. From this you can get the equation L1 divided by L1 minus L2 times B. L1 minus L2 times B. There you go. Okay. So it's a very nice question. They can give this for a structured essay as well. Don't forget. The same MCQ concept. They can give for a structured essay as well. Okay. Structured essay as well. Right. Next one. MCQ 44. MCQ 44. Read carefully. Two cubes A and B of same geometrical dimensions float in water. Float in water. As shown in the figure. Cube A has half the volume above water. So half the volume above means half above, half below. Okay. Half above, half below. Right. Same dimension means cube, same volume. Whereas B has 1/4 of the volume above. B has 1/4 above. 1/4 above means 3/4 below. Okay. So this is for A. This is for B, right? A and B. Simplify it carefully. If cube B is carefully placed on A, which of the following responses indicate the correct position of cubes A and B? Now look very carefully. Yeah? Now when cube B is kept on A, cube B is kept on A, what will happen? Cube B is kept on A, okay? Cube B is kept on A, something like this will happen. Let's work it carefully. Right, now look, now this weight of A, M1G, they are not saying same material, they are saying cube A, cube B, geometrical dimensions are the same. Upthrust is U1. Upward forces, balancers, downward forces. So if you calculate it carefully, upthrust is submerged volume, density of water into G. That is equal to M1G. I'll put equation number 1. All these cases we are using water, so we can go one more step ahead. I can put like this. V over 2 proportional to M1, M1G. This was okay. This one, weight is M2G, upthrust is U2, U2 balances M2G, upthrust is 3/4 rho WG, that is equal to M2G, rho WG common, 3/4 the volume proportional to M2G. Equation. Now what is happening here? Here the total weight is there, M1G is there separately, M2G is there separately, upthrust is U3. If I add 1 and 2 separately for your knowledge, 1 and 2 separately for your knowledge, V over 2 plus 3V over 4 proportional to M1G plus M2G. Half and 3/4. Half and 3/4. So if you add the volumes there, 1 and quarter, 5e over 4, 5e over 4, proportional to m1g plus m2g. What is m1g plus m2g? If I look at this, m1 plus m2g equals submerged volume density of water. So m1g plus m2g proportional to v dash, right? So what can you say about 5v over that? V plus v over 4. V plus v over 4. That means what? If I use a different color to show it, this whole thing is V, fully submerged V. This is V plus another quarter. So quarter of V, V over 4. V over 4 plus V. So A is fully submerged. Quarter of B is submerged. Correct answer is answer 3. So to obtain this total volume, that means V plus V over 4. A has gone underneath, total volume underneath. Another V over 4 is there. That V over 4 is coming from B. So A is fully submerged. From B, quarter is submerged. Correct answer is answer 3. Correct answer is answer 3. Again, a very good question. With basic logic, you can find it out. Yeah, basic logic. Right? Okay. 44. 45. MCQ 45. It's a big question to read, but the idea is same. A force F is applied to a piston. A smaller piston is here. Force F is applied to a smaller piston. 10 Newton. Area 2 centimeters square. Here there is a large force here. Area is 4 centimeters square. Okay. So what are they asking? When the surrounding temperature is decreased, the liquid inside is solidified. The solidified block moves freely inside the system, and a new force Q is produced due to the force F. Due to force F becomes F2. Respective values for F1 and F2 are. Respective values for F1 and F2 are. Let's look. Force F applied to a small piston 2 in a hydraulic system is shown in the figure. A force F1 larger on piston Q is acting. So liquid, no. Fully enclosed fluid. What's the rule? Pressure is equally transmitted. Pressure here, pressure there, pressure here, all are what? Pressure is equal to force divided by area. That's going to be 5 Newton per centimeter square. Here also pressure is equal to force divided by area. 5 equal F1 divided by 4 centimeter square. F1 equal 20 Newton. There you go. So this is the hydraulic fluid. There you go. Hydraulic fluid. So now what are they saying? When the temperature of the surrounding is decreased and it becomes a solid inside. Now temperature inside decreases. Now it becomes a solid inside. Now solid. Now look. Now what? Here we are applying a 10 Newton force. Now let's not talk about pressure. The pressure is not equally transmitted. Now they are saying the solidified block moves freely inside the system. the new force produced on Q due to the force F becomes F2. The respective values for F1 and F2 are now, once this becomes a solid, it's like this. It can't obey Pascal's principle. So 10 Newton here means guaranteed here also what 10 Newton. Solid. No? So 20 Newtons and 10 Newtons is there. Correct answer is answer number 2. Here cannot apply Pascal's principle. Cannot apply Pascal. For the hydraulic fluid, we can apply Pascal. You can apply Pascal's principle, right? When I push from this side, the other one should move. I mean, there should be a movement, volume change, volume exchange. So this is the one you can apply Pascal. The other one you can't apply Pascal. MCQ 46. Direct theory. Now the one we learned. When you are immersing a mass into the vessel, what happens? Tension will reduce. I hope you remember. Tension reduces, constant, then drops. What about the reaction scale? Reaction scale will increase, constant, sudden rise. That's how your reaction will change with time. With depth also same thing with depth. So correct answer is answer number 2. Correct answer is answer number 2. This is for B, this is for A. Correct answer is answer number 2. Correct answer is answer number 2. You can write it down. That is more sentence. We have directly learned this. We have directly learned this in theory. We have directly learned this in theory. When we keep immersing, the tension will reduce. When we keep immersing, the tension will reduce. When we keep immersing, the tension will reduce. Once it is fully submerged, the tension will remain constant. Once it is fully submerged, the tension will remain constant. Once it is fully submerged, the tension will remain constant. And once it touches the bottom, the tension will become 0. And once it touches the bottom, the tension will become 0. Once it touches the bottom, the tension will become 0. Initially, when the tension reduces, the reaction will increase. Initially, when the tension reduces, the reaction will increase. Initially, when the tension reduces, the reaction will increase. When it's fully submerged, it will remain constant. When it's fully submerged, it will remain constant. When it's fully submerged, it will remain constant. And when it touches the bottom, there's a sudden increase. And when it touches the bottom, there's a sudden increase. You can refer the theory note. Refer the theory note, it's there. This is just a basic idea you keep in your head. Okay. MCQ 50. MCQ 50. A boat made of metal floats in water with 1/5 of its volume submerged. There's a boat made with metal, 1/5 submerged. 1/5 submerged, right? So, weight of boat. Upthrust is there. Now they are telling another boat is made with a volume 3 times. Volume 3 times than the first. Using the same mass, same weight means upthrust is the same, but volume is 3 times. Ratio of the maximum load that can be carried by the second boat. Maximum load. Maximum load means how much weight you can carry. It's on the verge of sinking. It's on the verge of sinking. It's on the verge of sinking. V rho W. Here, volume now is 3 times. 3V rho WG. Maximum load it can carry MYG. Same weight MG. Simplify this. So here you can say directly. Mg balances V over 5 rho Wg. What can you say here? Volume is 3 times. Huh? Then 1/5 of this. Mg means 1/5 of this. Mg will be equal to 1/5 of 3 rho Wg. Now you write here mxg plus mg equals v rho Wg. mxg plus mg already found. V over 5 rho Wg. V rho Wg. All the g cancels off. Mx equals V minus VO means V minus VO5 means 4V over 5 rho W. Equation 1. Here MYG plus the weight equals 3V rho WG. 3V rho WG. Look at the board very carefully. Will. Sorry, here also. Whatever happens here, the submerged volume will be the same. Same weight is balanced. Submerged volume is the same. Same weight. Submerged volume is the same. Okay, no? This weight is balanced by 1/5. This weight also should balance by 1/5. MYG V over 5 rho WG 3V rho WG. My equals G cancel off 3V minus V over 5 15 minus 1 14 14 V over 5 rho W. Equation number 2. So they're asking the ratio. Asking the ratio. Okay, no? 3V minus V over 5 15 minus 1 14. My over mx 14V rho W divided by 5 divided by 4V rho W divided by 5. So if you they have given you here a boat made of metal floats in water with 1/5 of the volume submerged. Second boat is made with a volume 3 times. They have typed it 3 times. No? 3 times than the first. Using the same mass and the same metal. Same mass, same metal. Same mass means submerged volume is same. then the ratio is equal to, so if you divide here, 1402 is 7.2, 7.2, 3.5 ratio. But maybe there is a small error in the typing there in the question. But for the values given, this is your answer. Any correction before we finish today? We will check it. Okay. Right. Next one, MCQ 58. MCQ 58. MCQ 58. When a certain object is kept on water, it floats by immersing 75% of its volume. 75% of the volume means 3/4 of the volume immersed. Upthrust balances the weight. Okay. If the object is kept in a liquid with density 1.5 times the water, 1.5 times water, what's the percentage volume submerged? So let's find V dash here. Same weight. The same upthrust actually. If I submerge 3/4 the volume, rho Wg equals m1g. If I substitute here, V dash 1.5 rho Wg, that is equal to m1g. 1 and 2 are equal because both are equal to the same weight. So 3/4 V rho Wg, V dash 1.5 rho Wg. Simplify this. Rho Wg cancel off. Now here you have 0.75 divided by 1.5 V, that is V dash. Jump to decimal places. Therefore, V dash equals V over 2. V dash equal V over 2 means half the volume submerged. So percentage submerged volume divided by total volume multiplied by 100. That will give you what? 50% volume. 50%. 50%. So in water, 3/4 submerged. In a liquid, 1.5 rho W density, V dash submerged. V dash, find it, it's V over 2. Exactly half, 50%. Exactly half, 50%. Right? MCQ 60. MCQ 60. Inner sphere of a composite solid. Now there's a sphere here. Composite solid is made from material D1 density. Rest is made with material D2. They are marked and given. They are marked with dotted lines. Composite material. Radius of the inner sphere is R1. Radius of the outer sphere, I think, is R2. Right. If the composite sphere floats immersed in a liquid, what is D3? Okay. So now you can work this out. This part has a weight. This part has a weight. Everything should be balanced by the upthrust. Sum of forces in the upward direction balances sum of forces in the downward. Quickly, it must click. This part made from material, it has a weight. This part made from a material, it has a weight. Fully submerged and floating means there is upthrust. Weight of this section, what's the volume? 4/3 pi R1 cube D1G. Sorry, downward. I'll put the upthrust there. Composite part. What is the volume of this section? O-level geometry. 4/3 pi R2 cube minus R1 cube. Bigger volume minus smaller volume. into density d2 into g. What is touching the whole object? Whole volume is submerged. 4 over 3 pi r2 cube into d3g. Simplify this carefully. 4 over 3 pi g. 4 over 3 pi g. 4 over 3 pi g. What will you get? R1 cube d1 plus R2 cube minus R1 cube d2 equals R2 cube d3. See whether you have this answer. R1 cube d1 plus R2 cube d2 minus R1 cube d2 equals R2 cube d3. Answer is answer number 1. Weight of this part is downwards, weight of that part is downwards, that is balanced by upthrust. Remember, this part has a different material weight, this part has a different material weight. How do you find this volume? Bigger volume minus the smaller volume. Found here. Into density into G. Right? From there you have your answer. Right. Question 62. Question 62. A solid cube of plastic mass m, length 2x, floats in water. Length is 2x, floats in water. Right. Solid cube. Cube means all sides are equal. Right. Here also 2x. Don't forget here also 2x. Right. The cube is now converted into a hollow cube of mass m with external side of length 8x. The depth to which it will submerge in water. Solid cube. Mass m 2x floats with half one side submerged. Half submerged. Huh? So, Domina hurry, carefully write. Upward forces, balancers, downward forces. Area, don't forget 4x squared. Area times x volume, rho wg. Weight is capital Mg. Area is 4x squared into x, rho wg. That is equal to mg, gg cancel off. Capital M is 4x cube rho w. Now they're telling what? They're telling cube is now converted into a hollow cube of mass m, same mass, with external side length 8x. Now external side is 8x. 8x, 8x by 8x. Hollow, inside hollow. Huh? Weight is mg. Now what are they asking? Now they're asking you, now what is the submerged height? Remember this area is 64x squared. Huh? Again, whether it's solid or hollow, we don't really care. Upward forces, balancers, downward forces, upthrust is 64x squared h dash rho wg. That is equal to mg. 64x squared h dash rho w gg cancel off equals m. 64x squared h dash rho w 4x cubed. 4x cubed. Simplify this. Find h dash. H dash equals 4x cube rho w cancel off. 4x cube divided by 64x squared. X on top, 16 at the bottom. X over 16. X over 16 means answer number 4. So whether it's a solid or a hollow, what we really care is what? Weight and upthrust. Weight is same means upthrust is same. Accordingly, submerged volume will change. Accordingly, submerged volume will change. Right? MCQ 68. MCQ 68, very famous question. MCQ 68. Part of a huge man-made garbage dump on a large marshy land suddenly collapsed and sank, ejecting nearby houses up. The Kunukanda went in, lifting the houses up. Going in, lifting up. Okay. So there is a transfer. This transfer gives you what? Pascal's principle. So 68 is like answer number 4. Pascal's principle. This actually happened in Colombo. Actually happened somewhere in Colombo, bigger Colombo city, because normally in the Colombo city, every day 800 tons of solid waste is collected. 800 tons of solid waste, sometimes it's sent to the garbage dump, put it. So when the garbage dump adds up, in between there will be what? Air gap. And what happens is when this pushes down, there will be shifting of some people, they make their houses also in marshy land. So this will push. That movement is because of what? Pascal's principle. Yeah. Pascal's principle. Right? Okay. MCQ 72. MCQ 72. MCQ 72. A piece of metal is attached to the top of a rectangular wooden block that floats in water, as shown in the figure. 50% of the volume of the wooden block is submerged in water. 50% of the wooden block is submerged in water. The wooden block is here. 50% of the wooden block is submerged in water. That means V over 2 is submerged. Metal is here. Metal is here. Okay. The metal piece and the wooden block have the same mass. Interesting. Here weight mg. Here also weight mg. Okay. If the wooden block with the metal piece is flipped upside down, what would be the percentage of the volume of the wooden block submerged in water? Now look. They're asking a very interesting question. Now I flip this. Now when I flip this, what will happen? You will say, sir, weights are same. Yes, I can understand weights are same. But here, logic, here upthrust is acting completely on the block. The upthrust on the block only balances mg plus mg. Now mg here, there is upthrust on the metal also and upthrust on the block also. Part of this ub dash plus um equals mg plus mg. Think carefully and tell me. Upthrust on the block, this is equation 1, this is equation 2, 1 and 2 are equal. Upthrust on the block in the first case is upthrust on the block now plus upthrust on the metal. Part of the upthrust on the block now is taken by metal means upthrust on the block now is lesser. Lesser means submerged volume is less. Submerged volume is less means less than 50%. Answer is answer number 1. Earlier, the total weight was balanced by the upthrust on the block. Now, the total weight, there is upthrust on the metal. So, part of that is now taken by metal. The remaining only will be by the block, not the whole thing. So, remaining by the block means volume will be less than what? D over by upthrust is lesser. Upthrust on the block is lesser. UB dash is smaller than UB. Upthrust is lesser means submerged volume is less. Answer is answer number 1. Answer is answer number 1. Right. MCQ 73. YouTube problem. MCQ 73. Water and coconut are there. Show the expression. Remember, pressures at the common interface are equal. So here, if you take the YouTube, the common interface is here. Here there is a liquid, here there is a liquid. Common interface is here, P and Q. So pressure at P and Q are same. Pressure at P equals pressure at Q at the common interface. If it is separate liquid, that's separate liquid. So there you go. Statement A is correct. Statement B. Height above the common interface. This height is, I think, H1. This height, I think, is H2. That you can write. H1 rho 1 equals H2 rho 2. H1, this one is water. H1 rho W, rho oil. H1 rho W, H2 rho no. Correct. C. You can't equate the pressures here and here. Only at the common interface you can. So C is wrong. A and B correct. Right there. In a YouTube, only at the common interface the pressures are equal. Only at the common interface the pressures are equal. Only at the common interface the pressures are equal. Okay. We cannot equate the pressures at any other place. We cannot equate the pressures at any other place. Right. Final MCQ 74. Practical. Huh? Directly what we have done. Here now slowly we are submerging. Spring scale is there. I hope you remember reduction constant. Yes. Tension. Huh? Tension. What are they saying? The buoyant forces are given B1, B2, B3. And the readings are given as W1, W2, W3. So W1 is bigger. Outside is bigger. Then W2 will be lesser. Block is on the bottom. Reading is the smallest. What about the buoyant forces? B1 is smaller than B2, smaller than B3. B3 means buoyant. Fully submerged only B3. Partially submerged only B2. Outside only B1. So this connection is given where? Oh, sorry. Fully submerged. That means these two buoyant forces are equal. Here it's equal. B1 partially, block is partially submerged. Partially submerged. Fully submerged, B2, B3. Partially submerged, reading is more. Fully submerged, lesser, even lesser. So correct answer is answer number 5. So partially submerged case is there, not this. Partially submerged case, fully submerged at the bottom. Partially submerged means the reading is getting lesser. At the bottom only what? Smallest reading. Buoyant forces means upthrust. Less upthrust, full upthrust, here also full up. Answer is answer number 5. Okay. Right. So I hope at least now you all are working, doing the MCQs, doing the homework, and you're starting up and doing work. Also, you're looking through the discussion. This is also helpful for even the ones who have done it. For the ones who have not done it, you can slowly look at it and do it. Make sure you look at the theories always. Theories are very important. Using the theory, you can easily solve a lot of problems. Okay, then. That's it for today. Catch you next week with another edition of Helpline. Good night.